Okay, so this video is going to go ahead and explain a little bit the law of conservation of mass. Basically, there is in science, there's these things called laws. And what laws are relationships that you find in nature. They don't explain how something happens or why something happens. They just explain that there's a relationship. Later on, we're going to see gas laws, and the gas laws basically show you the relationship between certain properties of gases. So, for example, Boyle's law basically tells you that when the volume of a gas is decreased, you compress a gas, you smash it in, its pressure increases. Or there's Charles' law that basically says as the temperature increases, you heat up a gas, its volume also increases. So they don't explain why. They just explain that there is that relationship between these properties. There's an inverse relationship between pressure and volume. As one gets bigger, the other gets smaller. And there's a direct relationship between volume and temperature. As one gets bigger, the other also gets bigger. So that's what we're going to be, that is what a law is, and we'll be seeing those laws in chapter 14 or so. This is one of the first laws we're looking at, and it's called the law of conservation of mass. And basically, as you can see, the first bullet point, basically what it says is that mass cannot be created or destroyed in a chemical reaction. It can only change forms. So if you have a chemical reaction occurring, you're going to take a couple of things, one, maybe two or three different substances. You're going to combine them, and when you combine them, there's a chemical reaction that takes place. There's actually a chemical change that takes place. And you're going to turn it into new substances. And those new substances are going to have different properties. You're going to find then, though, that what happened is that inside these substances, the substances, actually the elements in them, the atoms in them, just rearranged with each other, and they turned into new substances because there's a new combination of elements creating new substances. And when those occur, you get something new. But one thing you don't lose is mass, because it turns out that we're still keeping all the atoms that we start off with. They've just been rearranged, and each atom has mass, as we'll see in chapter 4. And so you can see in the second bullet point, it tells you that a way of looking at the law of conservation of mass is that the mass of the reactants, those are the substances that you had before the chemical reaction takes place, is going to be equal to the mass of the products. Right? Those are the substances you end up with at the end of the chemical reaction. Okay, so law of conservation of mass, basically mass cannot be created or destroyed in a chemical reaction. It can only change forms. And the way we can, another way we can show it is that the mass of the reactants equals the mass of the products. Okay. So we can do simple problems in order to show what, that works. Okay, so here we have sample problem number 1. You're given the chemical reaction, what happens during this chemical reaction. You're going to have the element nitrogen and the element hydrogen, and those two elements are going to combine to form a substance called ammonia. Ammonia is a substance made up of nitrogens and hydrogens bonded together. So you got nitrogen by itself, hydrogen by itself, you combine them and you're going to form ammonia. Now the problem is in the second one here. The question is, how many grams of ammonia are formed if 14 grams of nitrogen react with 2 grams of hydrogen? Okay, so how many grams of ammonia are we going to end up with? Okay. Let's go ahead and see how we can do this problem. Okay, so here I have the problem over here that we just read. What I'm going to do is I'm going to put this in the form of a chemical equation. And a chemical equation is when you separate what we call the reactants from the products. The reactants are what was here first. The products are what we ended up with. So nitrogen and hydrogen were there first, and they were combined. So I'm going to write this out as, let me use the pen here. nitrogen plus hydrogen. Bear with me with the drawing here. I still haven't gotten used to using this pad, and it's been all summer since I've actually used it. So nitrogen and hydrogen get together and they form ammonia. Okay, and so these are the reactants, this is the products. If you'll recall, the law of conservation of mass says mass of the products equals the mass of the reactants. So according to the problem, they're asked how many grams of ammonia are formed if 14 grams of nitrogen react with 2 grams of hydrogen. So we started off with 14 grams of nitrogen, and later on you'll be able to do these calculations on your own. You'll be able to calculate how many grams of each go with one or the other in the right proportions. There was 2 grams of hydrogen, and we're looking for the grams of ammonia. So let's say we'll call that an X. We're looking for it. So what we know is that if I add up these two guys, the two substances here on the left of the arrow, the two reactants, they should equal the mass of the products. Well, there's only one product, and that is ammonia, and that's what we're looking for. So our X that we're looking for, ammonia, is the 14 grams from the nitrogen plus 2 grams of the hydrogen. So add those two together, you're going to end up with 16 grams. That's going to be our X. That's the mass of ammonia. And so here you go. There's your answer. 16 grams of ammonia is what we're going to make. Okay, and that it was that simple. You can only do these problems if only one of the substances in your equation is unknown. Actually, later on, second semester, as long as you know one of these, you can figure out everything else, but that's kind of further down the line. So let's do a second problem. Okay, for sample problem 2, it's same idea. It's a little bit more involved because there's more substances involved in the chemical reaction here, but same idea. We're using the mass of the products is going to be equal to the mass of the reactants. So for sample problem 2, the first bullet point describes a reaction. Zinc reacts with hydrochloric acid to form zinc chloride and hydrogen gas. We've got it up here. Second bullet point here, we're rewriting this in a chemical equation format, where we're putting the reactants on the left side of an arrow. The arrow is in the middle to separate the reactants from the products. Think of it as the before and the after. And before, we start off with zinc and hydrochloric acid. Those were the two substances. We mixed those two. And those turned into zinc chloride and hydrogen. Okay, so these are your products. The question states, if 22.3 grams of zinc react with 15.5 grams of hydrochloric acid, how many grams of hydrogen gas are formed if 28.5 grams of zinc chloride are formed? This is the problem that we're going to try to solve here. So the second problem is a little bit more involved, the same idea. We have, this chemical equation already set up for us. Zinc and hydrochloric acid goes to form zinc chloride and hydrogen. So let me write that out. Zinc, let me see. Once again, I have to choose my pen here. Zinc and hydrochloric acid. Those are my two reactants. Oh. And that goes to form zinc chloride and hydrogen. Okay, so remember, our total mass of the reactants has to equal the total mass of the products. And we're told that we have 22.3 grams of zinc. So zinc is over here by itself, 22.3 grams. and it's reacting with 15.5 grams of hydrochloric acid. So there's 15.5 of hydrochloric acid. 8 grams of hydrogen gas. We're looking for hydrogen gas. Formed if 28.5 grams of zinc chloride. So it's 28.5 grams of zinc chloride. So these are the two reactants. We have to add them together. These are the two products. We have to add them together. And they have to equal each other. And there's our equation right there. So I'm going to go ahead and move this up just a little bit. Okay, so our question is gone, but we can still go ahead and do the problem. And basically all we're going to do now is we're going to solve for x, right? How much hydrogen. So I'm going to go ahead and subtract. First off, let me add these two together. 22.3 plus 15.5 gives me what? 20, 35, 37, 37.8? 37.8 grams. That's going to equal to 28.5 grams plus x. In order to solve for x, I subtract 28.5 grams from both sides, minus 28.5 grams from that side also. And I get on this side, I get that these cancel, leaving me with x equals to 37.8 minus 28.5. That's going to give me, what's that, 9.3 grams. And there is your answer. Okay, 28.5 plus 9.3 is going to give you 37.8. Okay, which is the sum of these two guys right here, added up to 37.8. So now these two guys right here have to add up to 37.8. Okay, so that's how you do these problems. They're relatively simple. You just have to kind of set them up so that you know what's the reactant. In other words, what was being mixed together at the beginning. What's the product? What was one of the final products, or the final substances that ended up there at the end of the reaction? And you just add the products together, add the reactants together. One of them's got to be an unknown, so I just plugged in x, and then I solve for it. Okay, that's how you do these problems.